Okay, so couple of things we want to make sure we go over today. And we've talked briefly about time, just in terms of those compound units. You know, if we have something that's listed as 500 gallons per hour, how are we going to turn that into cubic feet per minute? Well, 500 gallons over 1 hour, right? Then what? Which one do you want to get rid of first, the hours or the gallons? It doesn't matter to me. So gallons have to go on bottom. What has to go above them? Gallons are going to become what? Cubic feet. It's gallons per hour, cubic feet per minute. So gallons are going to become cubic feet. What's the relationship between cubic feet and gallons?
1 cubic foot equals 7.5 gallons.
1 cubic foot is 7.5 gallons. Good. So the gallons are gone. We're now in cubic feet per hour. We want the cubic feet. We don't want the hour. Where do I put the hour here to get rid of it? On top. Because it was on bottom, we put it on top so it cancels. And we're changing hours into minutes. Our relationship? 1 hour equals 60 minutes. So the hours cancel out. We now have cubic feet on top and minutes on bottom, which is what we want. Cubic feet on top, minutes on bottom. So on top, we've got 500 cubic feet. On bottom, we've got 1 times 7.5 times 60 minutes, which is, what, 450 minutes? .11 cubic feet per minute. $500 gallons in an hour sounds like a lot. It is not. A typical pump can pump closer to 5,000 gallons in an hour. That would be typically what they would call like a 12 CFM pump. 12 cubic feet per minute is about 5,000 gallons in an hour. It's a lot of fluid. So I got 0.8 milligrams per second. Want to convert that to milligrams per millisecond. That's 0.8 milligrams in 1 second. Are the milligrams changing? Yeah, milligrams and milligrams. The milligrams are not changing, so we'll just leave that as 0.8 milligrams. The seconds, however, are becoming milliseconds. What's the relationship between seconds and milliseconds? 3 spots there. 1,000 milliseconds. So that's 0.0008 milligrams per millisecond. What do you think? I can stop yawning at you. Of course, you guys have seen with electricity these prefixes for like milliamps and kilovolts, kiloohms typically, mega ohms. Let's say that we have, let's do the math with these. Your voltage is equal to current times resistance. Find the voltage when your current is 200 microamps and your resistance is 1.5 kilo ohms. See if you guys can remember how to do that. Well, micro is what, power of 10? Ten to the negative 6. So 200 microamps is 200 times 10 to the negative 6 amps. Kilo is 1,000, so 10 to the third. So 1.5 kilo ohms is 1.5 times 10 to the third ohms. So now we're going to multiply. 200 times 1.5 is 300. 10 to the negative 6 times 10 to the negative 3, or 10 to the positive 3. When we multiply powers of 10, we add the powers. Negative 6 plus 3 is negative 3. Amp times ohm is a volt. 300 times 10 to the negative 3 volts is 300 millivolts. Because 10 to the negative 3 is milli. Or 0.3 volts if you want to think of it that way. So before we do too much in review, I want to take a look at the one new concept for today. That's temperature. What's that? We have two temperature scales. We have the Fahrenheit scale, which is our standard scale, and the Celsius scale, which is our metric scale. And we have chosen to scale them, to calibrate them based on water. The temperature at which water freezes and thaws, and the temperature at which water boils. In the Fahrenheit scale, our standard scale, what temperature does water freeze at? Not negative, positive, 32. It's 32 degrees. What temperature does water boil at? Well, very good. Not too many people know that anymore. We had to memorize that when I was in elementary school, and I don't know if they just don't do it anymore or what, but a lot of people don't know that. Yeah. The math fairy is on your side today. On the Celsius scale, water freezes at what temperature? 0 degrees Celsius. And boils at 100 degrees Celsius. The Celsius scale is sometimes called the centigrade. Centi means 100, grade means divisions. So centigrade is 100 divisions. That term doesn't get used much anymore. It's kind of outdated. Now there's a couple of issues here. First, you'll notice if I subtract here 212 to 312, or 32, sorry, that's 180 degrees. If I subtract here, that's only 100 degrees. So what's telling me is each degree Celsius covers a bigger temperature range than each degree Fahrenheit. Because it only takes 100 degrees to get from freezing to boiling in Celsius, but 180 in Fahrenheit. The bigger problem, the biggest issue here is that there is no common 0 point. In every other measurement we have, there's a common 0 point. Like 0 centimeters equals 0 inches. Or 0 kilograms equals 0 pounds. 0 gallons equals 0 liters. I mean, there's a common 0 point. So we can just do those conversions like that. In temperature, since there is not a common 0 point, we have to use a formula to convert. So if I have the temperature in degrees Fahrenheit and I am converting to degrees Celsius, the Celsius temperature is equal to the Fahrenheit temperature minus 32 times the ratio here of the 180 to 100, 100 over 180 is 5/9. So times 5/9. So let's do human body temperature. What's human body temperature in Fahrenheit? 98.6 degrees Fahrenheit. So let's convert that into degrees Celsius. (98.6 minus 32). (98.6 minus 32 is 66.6. Times 5/9. 37 degrees. So human body temperature is 37 degrees Celsius. Let's go the other way. What's that?
Just a minute to finish writing that down.
Sure.
All right.
To go from degrees Celsius to degrees Fahrenheit, your Fahrenheit temperature is equal to 9/5 times your Celsius temperature. That's just that ratio flipped upside down. Instead of 5/9, it's 9/5. Then you add that 32 degrees to it. So let's say you turn on the radio and your weatherman on the radio is a weirdo. Says it's going to be 20 degrees Celsius today. Now in Fahrenheit, 20 degrees is a cold freaking day. Is 20 degrees Celsius a cold day? Well,
Do we use parentheses around the C?
no, not really. No, you don't need. It's not C plus 32. It's 9/5 C and then plus 32. So 9/5 times C is 36. Then plus the 32 is 68 degrees Fahrenheit. I will take that any day. That's about the perfect temperature for me. So I'm going to have you guys do a conversion for me. Negative 40 degrees Celsius. How much does that equal in degrees Fahrenheit? So we have our formula. Degrees Fahrenheit is equal to 9/5 times Celsius, so times negative 40. I'm just putting in parentheses because it's negative. And then plus 32. Well, 9/5 times negative 40 is a negative 72. Plus 32 is a negative 40. That is the one temperature that's the same on both scales. In your book, this stuff is covered on page 154, 1 through 31 odd. On page 156, 1 through 19 odd. Wanted to throw that homework out there before we started some review. Obviously tomorrow is your test. And I'm just assuming you guys would like to review just a touch before we do the test.
Test today?
Or tomorrow.
Tomorrow, yeah.
So let's review a touch. Two biggest things that I think you should review, that I think you need to review, or at least that I'm going to review, put it that way. Is this. How do I make that conversion? Okay, how?
432 inches squared over 1 times 1 or times square feet or cubic feet.
Careful.
Oh, square. Oh, sorry.
So 144 is our conversion. There you go. So it's 432 square feet over 144, and you divide that out, you get 3 square feet. So it's a matter of getting the correct conversion factor. How about this one?
567 over cubic feet over 1 times cubic yard, or no, cubic yard over cubic feet.
Yep. Now 1 cubic yard is how many cubic feet?
27.
You got it, it's cubed, so 3 cubes, 27. So the cubic feet are gone. 567 cubic yards over 27, which is 21 cubic yards. How would you do something like this?
So, first, add the 8 and 11 times the 19.
Perfect. 10 to the 8th times 10 to the 11th. You add the powers when you multiply exponents with the same base. So 8 and 11 make 19. So 10 to the 19th. Okay, and then?
We do the same to the bottom.
Okay.
5 plus 12, which is positive 7.
10 to the negative 5th times 10 to the 12th is 10 to the positive 7. And then?
You would subtract 10 to the 19th to 10 to the 7th.
Okay, so when you divide 10 to the 19th divided by 10 to the 7th, you subtract the powers when you divide exponents with the same base. So 19 minus 7 is, so it's 10 to the 12th to the 3rd power. When you take a power of a power, you multiply the powers. So 12 times 3 is 36. So here what I do, this is multiplication.
Yeah, you take a shot at
Well, not here. The parentheses are just separating out, saying that this is one number here, this is one number here, and a second number here. But when you multiply, you combine the counts. 4.5 times 7.6, which is 34.2. Then you combine the names. 10 to the 5th times 10 to the 7th is 10 to the 12th. Good. Now what's the problem with this right now?
We only have one number in front of the decimal.
can only have one digit in front of the decimal point. So I got to move it over, make that 3.42. Does the power get bigger or smaller? The number got smaller, so the power has to get larger. This went from 34 down to 3, so this gets larger. 12 plus 1 is 13. That would be it right there. So here, 2.21 divided by 2.6. 0.85. Yep. Times 10 to the... Careful. Oh, it is negative 4. You're right. Negative 9. Then what? It's got to go that way to make that 8.5, because you can't have just 0 in front of a decimal point. Does the power have to get smaller or larger? The number got larger, went from 0.8 up to 8, so the power has to get smaller. So you subtract 1. So negative 4 minus 1 is a negative 5. 8.5 times 10 to the negative 5. If you understand that part, you should be good to go.
Okay.
So then back to those pages for your homework
In the textbook.
in the textbook. Yep,
We're
you're
done with the pack.
done with the pack.